We're going to do a brief overview of the cable TV and off-air features of the XR-3 modular test instrument. As you can see on the rear of the unit, we presently have the cable TV and off-air module inserted into the XR-3 base unit. And presently we're on the main run screen. In the top left corner of the screen, we have the name of the presently selected channel plan, in this example EIA standard. Next to that, the selected channel number and the related channel frequency. And in the top right corner, we have the signal type that's been detected, in this case QAM256. We have the 6 soft keys around the edges of the main run screen. The spectrum shortcut soft key, the channel scan soft key, favorites graph, the tune by channel or tune by frequency, the Constellation bit error rate shortcut soft key, and the shortcut to get to the main menu. To tune to different channels within the channel plan, since we're in the tune by channel mode, as we can see with the gray rectangle around the channel, we can press the meter's up or down arrow buttons or type the desired channel number into the numeric keypad and press enter. So we're just going to press the up or down arrow keys to toggle between the various channels. And as you can see, the related frequency changed as well. If we want to tune by frequency, we can select the tune by channel or tune by frequency shortcut soft key there, and now it's switched into tune by frequency mode, where it's showing you the raw RF level that's being measured at the selected frequency. So if we want to tune to a different frequency, for example 500 megahertz, we would type 500, enter into the numeric keypad, and as you can see, it's showing under for the RF level, which means that the RF level is less than -40 dBmV. So we're going to then go to the tune by channel mode again, pressing the top right soft key, and it will take us to the nearest channel in the channel plan to the 500 megahertz. In this case, channel 69 at 495 megahertz. To look at our different channel plans that we have to choose from, we can press the menu soft key in the bottom right hand corner, and then press enter when channel plans is highlighted. And here it shows us the various channel plans to choose from, the standard plans as well as our custom plans. So under the standard cable plans, the top section, presently we have the EIA standard plan selected. This would be the cable TV plan for North America, the most common one for North America. That would be for both analog, EIA analog, as well as the digital Annex B, J.83 Annex B, QAM64 and 256 signals. And there are other cable plan options down below, HRC, IRC, PAL, and SECAM. Below that, our second section are the standard off-air plans in the meter. The most common for North America, which is the NTSC, ATSC, which is for VHF and UHF, both analog and 8 VSB digital signals. And it will auto-detect whether it's analog or digital, just as it does in the EIA standard plan for cable. And then the FM North America plan, which would be used to tune an FM antenna at the various FM frequencies. Down below, there's a custom plan section, and as you can see, we have a few different examples of plans loaded in here that we created. Cincinnati ATSC, Denver ATSC, Indianapolis ATSC, and Louisville ATSC. So we're going to go back and we're going to choose the EIA standard, which we had selected previously, and press enter. So now we're going to do a channel scan to see what channels exist on the system that we're connected to. So we're going to press the channel scan soft key, and we'll stand by, and it's scanning through the different channels in the plan. So as the screen is scrolling here, we can see the RF level and quality that's being detected for each of the channels. In the lock/delta VA column, we can see for a digital channel, if the signal locked, and if it's an analog channel, it would give us a delta video audio reading in that column. And then the pass or fail column would indicate a pass or fail if we have a limits file active, which we presently do, and we'll go over the limits shortly. If we want to see this in graph view as it's scrolling through the different channels, we can do that. So graphically, the channels in red are failing based on the limits that we presently have selected and programmed. Yellow is marginal for both the level and quality, and the green is passing. And then the gray column is the presently selected channel that it's scanning. We're going to go back to our table view now as it finishes up the channel scan for this system. Okay, so now that the scan is complete, since we have selected some tilt channels, it actually gives a tilt measurement there at the bottom of the screen. If we want to see a summary that was done of the scan, the overall scan result was a fail. We had 91 channels passing and 61 failing. It scanned 157 channels and it discovered 101 analog and digital channels, found 98 digital channels and 3 analog. If we want to see further summary of the digital channels, press View Digital, and it will give you the minimum level and max level and minimum quality and max quality and the tilt values that were detected during the scan. And if we want to do the same for the analog, press View Analog, and it'll give us a summary there of the minimum max levels and minimum max carrier to noise ratios and minimum max delta video audio and the tilt measurements. So I'm now going to go back to the overall scan and back again, and we can see when I toggle with my up down arrow buttons, this far right column is my favorite or tilt column, and I can select up to 5 favorite and tilt channels. The 2 tilt channels count against your 5 favorites, and those 5 favorites will allow us to use the favorite scan feature that we'll go over shortly. So if we want to change that with your presently selected channel, you would then press the Fav Tilt soft key down below on the numeric keypad, in this case the number 1 that corresponds to the Fav Tilt soft key above it, and it would then erase the Fav Tilt selection, and then if I press it once it puts a yellow star denoting a favorite channel, and if I press it again you'll see the T with the circle around it denoting a tilt channel. So we now have our 5 selected favorite channels already. And then if we want to save the channel scan, we can save this channel scan in a few different ways. We can save it as a regular scan file. That would be if we just want to log the measurements on the system. Or we could save the found channels as a new channel plan. So if we just walked up to a hotel property and we wanted to create a custom channel plan for this property, and we really only want to toggle between the channels that are present on the hotel system, then it's handy to have a custom channel plan, for example, a Hilton or something, we can name it whatever it may be. So we're just we'll save it as a few different file types. We're first going to save it as a scan file. So we're just going to call this Comcast. I'm using the numeric keypad to type my letters for the file name. And I press enter after each field's contents are put in there. If you want to, you can enter further details in the notes field, and then I'll press save. So I saved that as a scan results. Now I'm going to also save this as I'm going to save the found channels as a new channel plan. So I'm going to save it, I'm going to also name it Comcast. And then our location we have as AI for applied instruments. The technician name, you can put the initials or the full name, whatever it may be, and your notes. So I'm going to now save the channel plan. Tell me that's been saved. And if you just make some changes to an existing plan, for example, for favorites or tilts, whichever are selected, then you can just save your favorites and tilt changes to the plan if you've done some changes on those, which we didn't in this case, so we won't do that. So now I'm going to exit here. And I should point out that on the bar graphs, the red, yellow, and green, they are tied to different limits, as I mentioned earlier, green being passing, yellow being marginal, red being failing. If we want to modify or select a new limits file, we can go in here to Menu and then toggle down to Limits. And in this case, presently, I created an example plan called STB for set-top box. So if you wanted to edit that, you could, while this is selected, you could press the Edit soft key, or if you want to create a new one or delete it, you just use the related soft keys there. So we do have the set-top box limits file active at the moment. And if I want to see a favorites graph, which is handy while you're tuning an amplifier in RF MDU system, or while you're tuning an off-air antenna, because these 5 channels are updated in real time. So you can see here that we have our 5 channels. So if you're adjusting an amplifier in an MDU system or adjusting an off-air antenna where there's some transmitter towers located in different sides of town, it sort of ends up being a compromise, and you want to see the effect on multiple channels. So we can see basically in real time here the RF level and quality of up to 5 favorite channels on the screen at once. So it shows us the lock status of the digital channels, or the carrier to noise, and our RF level for the analog channel. And if you want to save that, you can go to the table view here, and it will then scan through up to 5 favorite and tilt channels, and allows you to see a summary of those. In this case, we had 4 passing and 1 failing, just as we did in the channel scan. But that's very handy to be able to see up to 5 channels in real time there as you're making an adjustment, either to an amplifier in an MDU system or adjusting an off-air antenna. So we're going to go ahead and exit. Now let's take a look at the Constellation and bit error rate screen. So I'm going to tune to channel 2, and I'm going to press my Constellation bit error rate soft key. In this example, it's a QAM256 channel that's been detected, and no errors have been detected yet, which is great, either pre-FEC or post-FEC errors. Oh, now we're getting some pre-FEC errors that are being detected, but at the moment they are all being corrected in the post-forward error correction scheme. And then we have our related channel frequency and channel number in the top left-hand corner. The elapsed time, so 34 seconds and 35 seconds, and it will continue to go up. If we want to zoom in on a particular quadrant of these 256 squares for the QAM256 signal, we can press the Zoom Select soft key, and then our 4 arrow buttons on the meter's keypad area to select which quadrant we want to zoom into. And then when you've chosen the desired quadrant, press the Enter button. And now we can take a better look at these 64 squares out of the QAM256 signal. And we can save the Constellation scan, the bit error rate scan if desired or not. Here, as you can see, we're now getting pre-FEC errors and post-FEC errors, so there do appear to be some issues on channel 2. And I'm going to go ahead and exit the bit error rate screen. Now let's take a look at the toggle to channel 3, and we're going to take a look at the spectrum screen. So by default, since we were on channel 3, Our marker 1 will be centered at the digital, and that was detected as a digital carrier there, the channel 3, a QAM carrier. So the marker 1 will be at the center of the channel 3 carrier frequency. In the turquoise color up at the top edge of the spectrum, that's the peak hold value that's been detected. So then if it gets lower, that turquoise would stay there. That's the maximum RF level that's been detected at each one of those frequencies. And then the royal blue color down below is the presently detected RF power or RF level at each frequency that it's scanning through. And down below, it's color-coded, so marker 1 is the presently selected marker. With my left-right arrow buttons, if I want to toggle that marker 1, I can hit my left arrow button here and watch that marker 1 move in the related RF level down here that corresponds to marker 1. Then if I want to go to marker 2, I can press this top right soft key and it'll toggle to marker 2, which is in yellow, and the corresponding RF level for marker 2 is shown there, and I can then move marker 2 if I wanted to with my arrow buttons or by typing in the desired frequency to tune to for marker 2 and then press enter. If I want to change the spectrum menu settings, I could go to menu, or if I want to basically do a maximum level adjustment to take a better look at this, I can press the LVL soft key here, and as you can see, it's the same power that's being measured, but it adjusted the scale on the left based on the power levels that have been detected across the scanning range, so we can get a better look at the carrier. So that is advisable to get a better look at the carriers, to press your LVL auto leveling function soft key there after it's scanned across the screen once. And then if we want to change our spectrum menu settings, we can press the menu soft key and toggle to settings. And we can change the number of samples that are taken. The less samples that we take, the faster the sweep speed will be, but of course with fewer samples, we'll call it the resolution or the quality appearance of that will change. So if I change that down to 60 samples, for example, and come back out, we can see the difference. Some other functions, options within the spectrum menu, you can turn on or off the peak hold line and the vertical bar markers. You can set your ceiling and floor and the start and stop frequencies for the screen. So now I'm going to show you at 60 samples. Scans much quicker, but obviously the reason being it's taking fewer samples, so it's not quite as high resolution there with that. We can also save the different spectrum screen if we wish to, or add a reference. The reference is really handy when we're using our NS1 broadband noise test signal generator. And once we adjust and do an adjustment for the NS1 to normalize that, then you can add the NS1's normalization on, blend that into a spectrum scan of a coax cable to test coax cable run. Really handy. Those are all of the basic features of the XR-3, the cable air features. The same description of the operation would apply to the off-air signals as well, but of course instead of dealing with a QAM256 signal, you would be dealing with an 8 VSB digital signal, for example. If we want to toggle to a analog frequency, we could type in 499.25, enter, and then go to tune by channel mode. And now, instead of seeing an MER value on the right bar graph, we're seeing a carrier to noise measurement, and the delta video audio measurement, and the RF level of the video carrier for this analog carrier. And in the top right corner, instead of a QAM256 signal, as you can see, it's an NTSC analog signal. We mentioned one way to create a custom channel plan was to do the channel scan and then save the file, the found channels in the scan, as a new channel plan. But there are a few different ways to create a custom channel plan, that being one. So to go over those, we can press the menu soft key and then go to channel plans. And now you'll see the Comcast channel plan that we created as one of the custom plans. So if we wanted to activate that, we can just highlight it and press enter. And then only the found channels will be contained in that plan instead of all of the channels and related frequencies in the EIA standard lineup. But if we want to create a custom channel plan with the signal types for analog and digital cable, then we can highlight the EIA standard, for example, to use as our base plan, and then press the edit create soft key, and we can create a file name here. We're just going to call this test. And then we press next, and you can see the parent plan is EIA standard presently because that's the base channel plan lineup that we're using for our custom plan. We can press next, and we can then customize. If you want to delete any of the channels that were in the EIA standard lineup, you can do that. Or if you want to change from a QAM, if you know that your particular channel in your channel lineup was analog instead of QAM, we can highlight that channel and press enter, and then on the type, which we'll toggle to with our up-down arrow buttons, we can then change that with our left-right arrow buttons to analog, and assuming that it's a standard analog video channel, it would have one audio carrier, so we would leave it on subtype 1 audio, and it already does the different audio carrier offsets there for you. If you want to edit any of that, you're welcome to. The noise offset field down here is used to edit where you want to take the measurement of the noise floor next to the video carrier. In this case, the noise floor measurement is being taken at 1.25 megahertz below the video carrier frequency, but you can edit that as desired if you wish to take it at a different location, at a different frequency. So we changed our channel 2 there from a QAM to an analog signal, and then we can press back and just press save. Now under our custom channel plans, we'll see the new test channel plan down below that we just created from the base plan. The third method that you can use to create a custom channel plan or edit a base plan and create a custom channel plan is on a computer. It's for more advanced users using a text file there. If you wish to create a custom channel plan, editing the different fields within a text file, and then transferring that custom channel plan to the XR-3 using the MeterMate application, that's another option. If you want to adjust the screen brightness, you can press your screen brightness soft key below the audible tone, and then you can toggle there your screen brightness using the up or down arrow buttons, and press enter when that's done. Well, that's a brief overview there of the cable TV and off-air features of the XR-3. Hope you found it useful.